Now let's talk about SpaceClaim. Some of you may have seen SpaceClaim before, some may be new to it, but you must be wondering why SpaceClaim was originally developed. And the goal of SpaceClaim was to bring 3D modeling to every engineer. So people thought CAD and 3D was a little bit too hard. And the new engineers weren't there to use CAD 40 hours a week. They needed an easy-to-use tool where they could get in, do their job, and get out. So therefore, we knew we needed to make it fast, simple, and flexible. And so how do we do it? How do we make a tool that's simple, fast, and flexible? Well, the most important thing that we've done is really streamline the user interface. And you'll see over the course of the demonstration how I can use 4 tools, pull, move, fill, and combine, to make all of my edits to the model. And you'll be amazed at how easily it predicts what I'm going to do, guesses what I want to do next, and gives me a lot of feedback as I work with and change the model. And also, the other reason why we're flexible is that we have direct modeling. You'll notice that I can bring in geometry from any number of systems and immediately start to work with it. Because you don't need to know how a model was built to make some changes. If you want to add drafts to a model, go ahead and do it. If you want to develop a core and cavity for your mold design, no problem. Now, people today are using SpaceClaim for a number of different things. We have manufacturing people that are using it to make fixtures and tooling, designing and concepting from scratch, and also using it to simplify models for CAE. We're going to be mainly talking about SpaceClaim for injection molding today, how we can prepare it for MoldFlow or another mold package, how we can make a core and cavity for the actual mold assembly, and also how we can make edits to the plastic part so it's more idealized for the mold, the eventual mold assembly. And one thing I also want to mention is we have people today that are using SpaceClaim in the plastics market. Ed Sweets is using it at Bateman Plastics. And right now they're using it to make design changes on the fly. If they need to interact with a customer, they can do so by taking any existing geometry and quickly make edits to them. Now I also use MoldFlow to do a lot of their testing to make sure the design is going to work, and they're saving 60 to 70% of their time. And really, when you have time savings like that, it really enables you to take on a lot more business. So that's it for the PowerPoint slide. I don't want to have death by PowerPoint. So I'm going to get right into the demonstration. And remember, if you have questions about anything you've seen so far or anything you're about to see, remember to just type them into the chat box. Now this is SpaceClaim, and it's set up, and it looks like a 3D modeler. And yeah, we can bring in 3D models. I'm going to go ahead and open up a step file. So these are different file formats we can import directly from. Step, IGES, Parasolid, ACES, also ProE, SolidWorks, and Inventor. So if you have to interact with a lot of different customers and suppliers and vendors, and getting parts from a lot of systems, SpaceClaim is a great tool for this. Now we're going to look at this base design, the base for a small plastic part. We're going to look at some things we can do to this model and some changes we may want to make to it. And we'll look at this from a lot of different aspects, from a plastics design engineer to a manufacturing engineer, and also from the CAE aspect as well. Now, as soon as this part comes in, it comes in as a solid. Now, this original part could have been made in ProE, could have been made in SolidWorks, could have been made anywhere. But to us, it really doesn't matter. These are the 4 tools I was talking about: pull, move, fill, and combine. And I'm going to show you how those work and allow you to quickly and easily make changes to a model. Pull is the bread and butter of our system. Pull lets us select on anything we want and quickly make changes. I can select on walls, I can grab edges, and no matter what I select on, it makes a modification. This is the predictive interface I was talking about. If I click on an edge with pull, it knows I want to make a round, so this can be a little bit better for our plastic mold. It knows that if I have other rounds on the part, I can just snap them to the same size. So we can have rounds of only a few different sizes on the model. It's really nice to enable you to make a lot of changes very quickly. Now Move, on the other hand, lets us reposition things. If I grab spaces or elements in my design, we've decided to put them in a different spot based on some of our other configurations. Just move that around to a different location. And the great thing about it is, like I said, you don't have to know how this part was originally created. I might want a dimension from this wall to this wall. Or I might want a dimension to our holes over here. And it really doesn't matter what original datum these parts might have been dimensioned to. Just type in any dimension you want and add a parameter or a dimension on the fly. As soon as you see a change in SpaceClaim you want to make, go ahead and make it. You don't have to worry about how the part was originally created or what features were made to do it. This is direct modeling. If we have a support post and I would switch its position, I'll move it to a new area. We can slide it around edges, make a change, or I may decide that I need a few more to strengthen this. One finger on the control key copies that geometry, just like you'd copy a file in Windows or text in Word. We use a lot of the same shortcuts that you're familiar with. And so I don't have to rebuild this from scratch. I can just take this, copy it from one location to another. So you can immediately make your changes in your design as soon as you see them. And you know what? I don't even have to make a measurement to make sure they're in the right position. I can simply snap it into place and it immediately goes there. This is the power behind SpaceClaim and how it lets you make these edits simply, fast, in a flexible environment. And what I mean by flexible environment, so far we've been making all of our changes in 3D. But it might be easier to view this model and make changes in a 2D cross-section. No problem. SpaceClaim always lets you go into a cross-section anywhere you want on your design. Because we have our thin walls, we want to investigate them, interrogate them, make sure everything's okay. Or not only visualize it, but make changes to the model. We can still use those same pull and move tools while we're in this 2D cross-section. So you may want to add a round so this can be extracted from the mold. Or you may need to move this post to a new position. Everything you do in 3D can also be done in this convenient 2D cross-section. It's great here, but you'll see it shines even better when we're inside of our mold assembly. And the reason why we're able to make these changes is because we're actually making changes to the 3D model behind the scenes. So you can see as we change it in our 2D environment, the 3D updates at the same time. So let's say we're done making a few changes, and now we've really optimized it from the plastics engineering standpoint. Now the manufacturing guy takes a hold of this. There's a few things he might want to check before he okays this and starts to generate the core and the cavity. Now one important thing is to do a quick draft analysis. So we have this built into SpaceClaim, so you can take your model and quickly run a draft analysis of the part. And you can see it identifies different colors, green and red, which way the draft's going. Now you can always specify the direction of your draft, but SpaceClaim did a pretty good job the first time in predicting what I wanted to do. Now we may want to change the draft angle, set that to a different amount, because I know I need to have at least 1 degree. So I'll type in 1 degree and see where we're at. So it looks pretty good, like we're in pretty good shape, but there's a few things that I might want to take care of or look at. So we have our rim at the top, and that's probably okay. I'll probably still be able to get it out of the mold, but I may want to play with removing that and doing a quick run in MoldFlow before this. And I can see we have a lot of these ribs here aren't drafted. So we can take a look at that as well. Now the nice thing is that I have access to those 4 major tools in any window I want. all of them are on a ribbon bar as well. So we've looked at pull and move to create geometry and translate geometry, but let's look at fill for a second. And we'll get back into this a little bit more later as well. But fill is great because it allows you to select on anything you don't want and quickly remove it from your model with one single click. Get rid of those walls that aren't drafted. Or let's go to the pull tool. Pull lets us do all of our creation on the model. So for example, I can select on these faces and quickly pull them to make them larger or smaller. And you'll notice we don't have a lot of drop-downs in SpaceClaim that opens up different windows. Everything is on your desktop. Pull creates geometry, so maybe I want to revolve geometry. Maybe I want to sweep it along some trajectory. Or in this case, I want to add some drafts. Simply select the face you want to draft about and add that to your model. Now remember, I didn't make this model from scratch in SpaceClaim. This is imported geometry. And I don't have to add an intent or a feature tree on top of this. I can simply select the faces I want to edit, grab all those faces the same size, either pull them to make them larger or smaller, or simply draft them about a wall. So it's really easy to go in there and make any changes you might want to make. And remember, you can do this whether you're in 3D or in a convenient 2D cross-section. So you can see how all of our undrafted walls are 90 degrees to the bottom. Simply select them and change the draft angle. 2, 4, we'll see what works best in this model. And now we can go back and check our draft analysis again. And you can see the walls that we've drafted are now okay. So it's a good idea to always verify your design before you move on to the next step. So now that we've added some drafts for manufacturing, we may want to check this out in MoldFlow or a similar system. And so for that, we may want to remove some geometry from this design. Now our fill tool is great for that. So we can remove small edges and clean them up, make faces equal to each other, or simply remove them altogether. If I have small faces that I want to remove, simply select them and fill them in. And this works whether I'm selecting on single faces or whether I'm grabbing a lot of faces. Select anything you want to get rid of and fill them in with one shot. I use it a lot to change holes or also remove them from a design. All you have to do is identify one single hole in the model and simply use pull to make them larger or smaller, or fill to remove them altogether. It's a breeze to simplify your design. When you're working with the geometry, you don't have to worry about regeneration failures. But so now we have our part. We like it, and we're ready to move forward for manufacturing. So one thing I'm going to do now is make a core and a cavity. Now remember, before I do this, if you have any questions, definitely type them into the chat box. Because we're going to have some time at the end to take these questions, and I want to make sure we answer any questions you may have about SpaceClaim. So now I made a new component called core and cavity. So what I'm going to do is take this single part and turn it into an assembly. You can design inside of your model very simply. So instead of creating anything from scratch, I'll simply reuse the geometry that's already there. And so what I did right now is make a simple block. I made a big block that surrounds our plastic part. And what I'm going to do is I'm going to create our core and cavity from this. And we've looked at pull to create geometry. Move simply translates and rotates things. fill simplifies and removes things, and combine does all of our add and subtract. So for example, I'm going to take this block and subtract that plastic part from it with 2 clicks. Now I've removed that plastic part from the model, and you can see that hole that's been placed there. Now the only thing I need to do is separate this into 2 different pieces. And it's really simple when you're editing your model in a direct fashion. Simply select the faces I want to cut it with and cut this into 2 different pieces. Now to look at it better, I like to change the colors of these models. I'm going to color the cavity blue. And now what we need to do is we need to turn all of this geometry in here blue as well, because I'm going to separate this into 2 single solids. And the best way to do this is to chop this up. And I like to just to work in a forward-moving fashion. I mean, I might take this green solid and I might cut it into 20 different pieces. But it doesn't matter. I'm just simply working with the model, the geometry that's there, and chopping this up. It's like taking a hacksaw to a part. I can simplify this, cut it up, make any changes with just a click of a button, and divide this into these different sections. So I've cut this up into, gosh, it looks like 12 different solids. But now I see that I have these sections isolated. So it's simply a matter of merging them back together. This should be blue, this should be blue, and this should be blue. And you can see that I'm slowly merging together all of the green solids back and all of the blue ones. So at the end of this, we'll have our green outer solid and our blue inner solid. Now, an important thing to do is to check this to make sure that we have this separated correctly. I'm going to go ahead and view this in a cross-section. Now, what I like is that I can take our cross-section and actually go down our entire part to check this to make sure it's okay. And as long as we have blue on the inside, pink in the middle, and green on the outside, we're okay. Now here I can see we have an issue. It seems like I forgot to merge those 2 solids together. But that's why it's no problem. I don't have to worry about reordering the feature tree, making some changes. As soon as I see a problem, I'll fix it. And now we have all of our faces clearly divided, blue, purple, and green, all the way throughout the model. And just so we can see it a little bit better, I'll go ahead and stretch these out. So you can see I've now generated the core and the cavity in this assembly. Now the last thing I should do is probably add this to my mold design or mold assembly. So why not bring in a part from another system altogether? I might want to insert another file into this. I can bring in a step file, or I can bring in any file from any other system. I might have a generic mold assembly in an IGES format. Why not bring that into my design as well and get started on it? SpaceClaim is great for allowing you to go quickly into a cross-section and position your assembly or position your part inside of the mold assembly. So I can simply take our parts and start to move them around to a different position. Here I want to snap this up to the intersection. And now it's simply a matter of taking those 2, the core and cavity that I generated, and bring them into this mold assembly. Just so we can see it better, I'm going to hide some of these parts. So we can see we have our blue mold and our red part. No problem. Simply merge them together into one solid. Now I've added all that feature in the design into our mold assembly. If I want to do the opposite, I'll go ahead and bring this back and now simply cut it away. So we have our part, our design that's there, combine, and cut this away from our model. SpaceClaim is such a great tool for preparing your designs and doing these Boolean adds and Boolean subtractions. So now I can simply merge these together into one single design. So now I've taken what I've generated and added that into my mold assembly. And just so we can better see it, you may want to go through and just create a quick little exploded view. That way we can see all of the levels of the mold assembly and all of the parts that go along with it. Now the last thing I may want to do, take any of the parts that we've created and we've quickly generated today, and I can always throw this onto a quick drawing sheet and add in any annotations and dimensions I need for manufacturing. And so that's how SpaceClaim is really useful for injection molding. SpaceClaim can work with plastic parts. We can work with parts and assemblies, quickly create cores and cavities, and generate drawing sheets from them. So I said it was going to be a quick little demonstration so you can see some of the capabilities of SpaceClaim. And so now I think it's a great time to pause for questions. So remember, you can go and type your questions into the chat box on the right side of your screen. I'm going to go ahead and answer some of them. So one of the questions is, how do you deal with lightweight solids? So there's a few things we do to deal with lightweight geometry. First of all, I'm going to go back to SpaceClaim for a second. I just want to point out that we import geometry from a lot of formats. For the most part, we deal with solid BRET models. But we do allow you to import lightweight data like STL files. So when you bring in STL files, you can actually build around them and reference the facets that are there. So that way you can recreate a lot of the geometry and use that for your mold design. Now as far as exporting lightweight data, we export STL files, OBJ files for rendering, and also VRML files if you're doing 3D printing. Now, just one more thing on the export capabilities. For analysis or for creating the parts, you can also go through and export step files, IGES files, Parasolid, ACES files, and bring this geometry into any other system. So we have another follow-up question, is there going to be a video of this afterwards? And yes, we will post this video online, probably in 2 or 3 days, so you can send this to anyone else who may want to view it. And there's also a lot of videos on our website. So you can go to our website and view videos on manufacturing, concept modeling, a lot of other use cases. So another question I have is, what about standard parts that are there? So if I wanted to bring in a standard part into this assembly, we do have trace parts, which is a library of standard parts. So if I go to File, Insert, I can actually access our trace parts web. So I have to excuse me, I have a lot of extra windows open. But so we allow you to access trace parts. So you can basically just search for any parts you want. So if I was looking for an ejector pin, provided I could spell ejector, you can go and search for different ones that you might want to bring inside of your assembly. So a lot of parts that are already there. And again, you can order parts from these companies, but a lot of times you might just want to grab on them and reuse some data. So pick the size you want. It'll show you a quick preview of it, and you can add it to your part caddy and actually import it into your design. So for example, you can add it to your caddy, continue searching, and then once it's loaded up, you can insert that into the design you're working on. And I think it's really useful because a lot of times I don't have the screws or the nuts or bolts that I want to work with, and I just want to bring that into my model. And so insert that in, and now I can use this ejector pin and place this into my assembly. Look at a few other questions. Just have a few more minutes. So one question is, how do you deal with real-world step files with molding? A question basically on cleaning models before you work with it. Now, it sounds like a few of you have been burned in the past, and actually I have as well. A lot of times when you get IGES files or step files in, they can just be god-awful dirty. And so what you need to do is we have this repair tool that's specifically designed for that. So the repair capabilities actually allow you to repair models and bring them back into a 3D solid if you start to get just surface geometry in, and basically surfaces with a zero thickness, essentially. So we allow you three main ways to simplify them, are to stitch all of the faces together into a single model, and then search for any faces that are just completely missing off the part, or small gaps between faces that are causing it to be not watertight. And once you make it into a 3D solid, then you can use all of those 3D tools on the design. So you can pull things, you can move things, or you can create that core and cavity to generate your mold assembly. So thank you very much for attending today's webinar. Hope you've seen some of the ways SpaceClaim can work with plastics engineers, work with mold designers, to give them a really easy way to work with 3D models. Thank you very much for attending. Bye.